This video will cover the first page of notes for the topic of exponential and logarithmic equations. First, let's cover solving exponential equations. We basically have two types. The first type is when we can get the same basis for our problem. One easy way to look at this is to see if we can find one that's already in a simple form. In this case, I have a base of 4. The next question is, can I get the other one to be something in the form of 4 to some exponent? What we do know is because we have a fraction 1 over 64, we can write 64 to the negative 1 power, and that will give me the same thing as 1 over 64. So the next question is, can I write 64 in terms of 4 to some exponent? And the answer is yes. We should know that 4 cubed is equal to 64. So that means I can rewrite this particular fraction of 1 over 64 as 4 to the third power, but with a reciprocal, and that's why it needs that negative exponent. And that's what we see inside our parentheses here. We still have the exponent of 2x plus 1, and that's okay. The next thing we're going to do is we're going to combine those two exponents. So when I have a power to the power, that means if I have b to the m to the nth power, it's the same thing as b to the m times n exponent. So remember, I'm going to use the distributive property here because I have two terms in my exponent on the outside exponent. So I'm going to multiply negative 3 times 2 and negative 3 times 1. That's how I'm getting 4 to the negative 6x minus 3 exponent. Now that we have the same base, then we can sit there and say that the exponent must equal to each other. And that's how I have x is equal to negative 6x minus 3. And our job now is to solve for x. I'm going to add 6x to both sides, and I'm going to find 7x is equal to negative 3. And then I can see I divide both sides by 7, and I find my solution set of x equaling negative 3 over 7. The second type of exponential equation that we may be asked to solve is when we are not able to get the same base. Notice I have 4 on the left, and on the right I have 1 over 7 as a base. So I know I can rewrite 1/7 as 7 to the negative 1 exponent. But the question is, can I write either of these in terms of each other? In other words, do I know 4 to some exponent in which it would equal to 7, or do I know 7 to some exponent that would give me something like 4? So since we cannot rewrite the bases as a common base, we're going to take the log of both sides. Just so that we can get rid of fractions, I'm going to rewrite 1/7 as 7 to the negative 1 power. When I do that, we can see that inside our parentheses, and now we have power to the power, we're going to multiply our two exponents here and doing the distributive property, and we can see that we're going to get 4 is equal to 7 to the negative 2x minus 1 exponent. Again, we are unable to get the same base, so we're going to take the log of both sides. Only because I already used natural log in the first type, I'm going to use common log of base 10 for this problem. So I'm going to take the log of both sides. That will give me the log of 4 is equal to the log of 7 to the exponent of negative 2x minus 1. I'm going to bring that exponent to the front using the third property of logs. And notice I put that in parentheses because I have two terms for that exponent. Once I've done that, then I'm going to divide both sides by log of 7, since I want to isolate my x variable. So I divided both sides by log of 7. Again, I have log of 4 divided by log of 7. We're going to leave it in that format as we are looking for exact values. On the right side, I have negative 2x minus 1, so we're going to add 1 to both sides. And now we have negative 2x is the same thing as log of 4 divided by log of 7 plus 1. Now we need to divide by -2, but notice I already have a fraction over here, so it can look kind of messy if I'm dividing by -2. One thing I want to remind you is that what we can do instead is to multiply by a -1/2. When I multiply by a -1/2 times my -2, fractions only do it with other fractions, negative and negative becomes positive, and my 2's will cancel out because I end up with 2 over 2, which is 1, and that's how I get 1x on the left. So I'm going to multiply by -1/2 to both sides. Remember, I'm going to do it for all the terms, multiplying by -1/2. We can see where I'm multiplying two fractions. At the top I get -1 log of 4, and at the bottom I get 2 times log of 7. And on the +1 here being multiplied by a -1/2, I just get -1/2. So we can see here our final answer for this problem to be x is equal to a negative log of 4 divided by 2 times the log of 7, all of that minus 1/2. And that concludes this video.